Here in section 5.3, we will discuss exponential and logarithmic integrals. As you recall, the derivative of an exponential function, so the derivative with respect to x of the exponential e to the x, is just e to the x. It's the easiest derivative to remember. And so with that in mind, the integral of e to the x is just e to the x plus a constant c. It's the easiest integral to remember as well. Let's look at some examples. Let's say we want to find the integral of 2 times e to the x dx. Well, since 2 is a constant, we can just pull it out front, and we get 2 times the integral of e to the x dx. So we have 2 times e to the x plus c. Okay, let's look at another example. The integral of 2 times e to the 2x. Now, one thing to note here is that we don't have just e to the x. It's e to something else. And whenever you have e to something else and you're taking an integral, you have to do u substitution. So let's let u equal 2x. So then du is 2dx. Well, that's really handy because we have a 2 and a dx here. So this integral is just the integral of e times 2x times 2dx. So that's going to be the integral of e to the 2x times du. So that's just the integral of e to the u times du. And the integral of e to the u du is just e to the u plus a constant c. And remember, u is 2x, so we get e to the 2x plus c. All right, for our next example, we have the integral of e to the x plus x dx. But remember, integrals work really nicely with addition and subtraction. So this is the same as the integral of e to the x dx plus the integral of x dx, which is just e to the x plus 1/2 x squared plus some constant c. The easiest way to think about this constant c, don't let it seem too tricky. Basically, all you need to do is do your integration like normal, and then for your very last step, throw on the plus c. Don't worry about it until the final step. One more example, e to the 3x plus 1. Like I said before, anytime you have something in the exponent that's not x, you have to use a u substitution. So here, let's let u equal 3x plus 1. So then du equals 3dx. Or another way to write that is that du over 3 equals dx. So we can make those substitutions in here, and we get the integral of e to the u times du over 3, which is just the integral of e to the u times 1/3 du. And now we can pull the constant out, and so we have 1/3 times the integral of e to the u du. And the integral of e to the u du is just 1/3 e to the u plus a constant c. But recall that u is 3x plus 1, so we have 1/3 times e to the 3x plus 1 plus some constant c. And our last example for this video is we want to find the integral of 5 times x times e to the minus x squared dx. Again, because we're dealing with something unusual in the exponent, we need to use u substitution. So let's let u equal minus x squared. So then du is minus 2x dx. Or another way to write that is du over minus 2x equals dx. So let's make that substitution. So we end up with the integral of 5 times x times e to the u times 1 over minus 2x times du. Now here, because we have this multiplication, this x and this x cancel out, and so we end up with the integral of minus 5 over 2 times e to the u du. But we can pull a constant out, so we have minus 5 over 2, the integral of e to the u du, which is minus 5 over 2 times e to the u. But remember, u is minus x squared, so it's minus 5 over 2 times e to the minus x squared plus a constant c.